Hello, my name is Karen Beatty, and I'm the Director of Science and Stewardship with the Nantucket Conservation Foundation. Along with my colleagues in the Department of Science and Stewardship, we would like to present some information on a wetland restoration plan that we are working on for our Windswept Cranberry Bog. Before we talk about Windswept specifically, I'd just like to give a shout out to the organization that we work for and introduce those of you who are not familiar with us. The Nantucket Conservation Foundation is a private nonprofit organization. We operate on Nantucket, and we're a land trust that has protected over 9,006 acres of conservation land on Nantucket Island, which is over 30% of the land area here. We are entirely membership supported, so if any of you are not members and would like to join us, we would love to have you be a part of our organization, and you can find more information about us on our website. In addition to being focused on acquisition and protecting land, we have a full-time year-round science staff that is actively involved in making management decisions about our properties and doing research on a number of rare resources that we have on our properties. So I'd like to introduce you to our science department staff, and each person in this picture is going to be presenting information on the various aspects of this work that they are involved with. Danielle Odell is our wildlife ecologist. Jen Carberg is our research program supervisor. Kelly Omond is our plant ecologist. Libby Buck is our ecological stewardship and research technician. And all of us, contact information for all of us can be found on our website if any of you are interested in getting in touch with us about some of the information we're going to present today. So first, I'd like to give a little bit of history about the Windswept Cranberry Bog on Nantucket. This is a site where cranberry cultivation began in the early 1900s, so it's been a cranberry bog for a long time. It's a human-constructed bog, so it was not a natural cranberry bog. The Conservation Foundation purchased the property in 1980, and it includes a total of 231 acres. 39 of those acres were former cultivated bogs, and 111 acres were natural wetlands. So as you can see from this map, a great deal of the property supports wetlands and likely historically supported wetlands. Cranberry cultivation was retired in 2018 by our board of directors due to cost constraints. Our organization also operates an additional cranberry bog at Milestone Bog, and we have decided to focus all of our cranberry cultivation work on Milestone Bog. So going forward, we're planning for a large-scale wetland restoration project on this property, and that's we'd like to share with you today some information on where we're at with this work and how it is going to be proceeding over the next couple of years. So we have some really fantastic partners on this project. We are working with the Massachusetts Division of Ecological Restoration, which has a specific program called the Cranberry Bog Program that is focused on assisting cranberry farmers with wetland restoration plans if they make a decision to no longer cultivate cranberries on their various properties. So Mass DER has been a great partner for us. They came and presented information to our annual meeting back in 2019 and have been working with us since then. One of the first things that we needed to do to plan for this restoration work was to confirm that the site did historically support wetlands. So we did a ground penetrating radar survey that was completed in November of 2019, although we do still have a little bit of additional work to do on that. And that was funded by the USDA, Department of Agriculture, Natural Resource Conservation Service, who is our other partner on this project. We have completed a restoration concept plan working with Mass DER, who hired some engineers to put together some concepts, initial concepts of how this work will move forward. And then we applied for priority project status with Mass DER's program, which will enable us to continue to work with them and benefit from their expertise. And also they will be helping us with not just funding the work, but also targeting other outside programs for funding to move this project forward. So we still have a lot of work to do. We're probably quite a few years away from being able to put any shovels in the ground on this project. In terms of next steps, what we hope to be working on relatively soon is a hydrology study to get a better handle on how the water is moving through the property and how groundwater is influencing what's going on there. There'll be a lot of surveying, engineering, and much more detailed plans that will need to get developed. There's an extensive permitting process that we need to go through. We need to do some grant writing, and then finally we will be in a point where we can initiate construction, and that will probably be a couple of years away. But we've made a lot of great progress in the last 2 years, and we're pretty excited about this. So I wanted to just share some information, general information on cranberry bog restoration, and the steps that I'm about to describe are kind of pretty universal in terms of most sites that were former cranberry bogs that are now being restored. These are restoration actions that need to happen in order for a wetland restoration project to move forward. So cranberry bogs, one of the things you need to do when you're cultivating cranberry bogs is you need to have very strict control over how the water moves through the property. So a series of dikes and berms are constructed to isolate each of the individual bogs and keep them hydrologically disconnected from each other. So one of the first things you want to do in a natural wetland when you're doing a restoration project is to remove those dikes and those berms and to encourage the water to flow through the property in a more natural way. So not only do you want the water to be able to flow in between the individual bogs, but you also want to reestablish wetland connections between the bogs and the natural wetlands that are surrounding the bogs. Over the course of cranberry cultivation, not every year, but almost every year, one of the processes that's done is to put sand on the surface of the bog to stimulate vine growth when you're growing cranberries. And over time, the elevation of the bog becomes higher and higher, and it becomes more separate from the groundwater. So another step in the restoration process is to reduce the elevation on the surface of the bog by removing that accumulated sand. There's an extensive system of internal and perimeter ditches around all of these bogs, which need to be filled in to create, to reduce channelization of water and provide more of a natural flow of water through the property. And then finally, another step that's done is to roughen the surface of the bog once you've taken the sand off, which helps to stimulate the growth of wetland plants to recolonize the surface and move the restoration process forward. So our organization has put a lot of time into setting some goals and priorities for this project on our particular property. One of our top goals is to restore natural wetland function, and what this will really help do is provide wetland habitat that is able to filter water as it moves from the surrounding uplands around our property through the bog and then out to Pulpus Harbor, which will substantially help to improve water quality in that area of the island. As a conservation organization, we're very interested in maintaining public access to our properties. Currently, the site has a good deal of trails that connect with literally thousands of acres of conservation land that surround the area. So we want to maintain those trail connections, provide some wetland crossing boardwalks so that people will be able to continue to enjoy the property and access the areas around it. And we do plan on doing a great deal of educational work with interpretive signs and also leading walks and things like that. Another big priority for us is Stump Pond, which is a beautiful human-made wetland that was created as part of the cultivation and construction process back in the 1900s, but now supports a very unique habitat on Nantucket. So although this is a human-made pond, we definitely want to maintain this pond, and so we're working with our partners at Mass DER to figure out a way to maintain that pond as part of the wetlands on the property moving forward. And then finally, it's an important goal for us to incorporate the results of all of the research that we're doing on the property to help guide where this restoration plan goes and come up with plans that are very specific to our site here on Nantucket. And towards that end, I would like to turn this over to Dr. Jen Carberg to talk a little bit more about some of the research work that we have been doing and are planning to do.
Thank you, Karen. So one of the amazing opportunities of a large-scale restoration project like this is that it creates room for all sorts of multiple research projects. So one of the things that the science department at NCF is uniquely geared towards is being able to do a lot of research on a lot of different topics. And you'll hear about some of those research projects today that we've already started, that we're planning on starting in the future. It also leaves room for us to invite researchers from all different areas to potentially contribute to research on this project. And as this will be a long-term and large-scale research project, it gives space for answering, hopefully, a lot of questions about restoration of the scale in cranberry bogs and in areas in New England where we can look at plant communities, the effects of soils with restoration, all sorts of different wildlife communities, looking at the potential to positively impact water quality through restoration, and potentially at some point, as most of the cranberry bogs within New England eventually end up connecting up with the ocean, potential impacts of sea level rise and how these wetlands can help mitigate sea level rise. Next slide, please. So one of the first projects that I worked on out on at the Windswept property was exploring the soils that currently exist out there and potentially exploring what we're going to create in the future through restoration. So soils are an extremely important part of what a wetland is. And looking at cranberry bogs, the way that we've cultivated cranberry bogs has impacted what those soils look like within the area. And really understanding what those soils are can help us understand where we'll be successful in doing wetland restoration. And Karen gave a little bit of the background on this, but last November of 2019, we actually went out to a majority of the separate bogs that are at Windswept and dug a lot of holes, a lot of deep holes, to try and categorize the different soils that existed within the cranberry bog itself and see what's actually underneath the cultivated part of the cranberry bog. The first couple layers of most of the bogs existed, as you see in the middle picture here. And that's that most cranberry bogs have dense layers of sand that intermixes with peat. And basically peat is organic soil that accumulates within wetlands. As vegetation dies back each year, it only slowly decomposes within soils that are actually wet and actually starts to accumulate as soil itself. So that's the organic soil layer that you find within cranberry bogs. These dense layers of sand and peat and the compaction of these layers on top of cranberry bogs actually limits water flow up to the roots of vegetation that's growing within the wetland. So one of the things we needed to categorize was how deep those layers of cranberry bog soils were, and then what was underneath those layers as well. And so one of the other layers that we found out there when we dug deep enough through those cranberry bog sand and peat layers was the picture that you see on the far right-hand side of the screen here, which is this really thick, very mushy clay layer. And clay layers, having clay layers within your wetlands actually makes for a really successful wetland restoration. Clay holds water above it. It will hold water within your peat soils. And so we were able to get out on the property and identify the areas that had these thick layers of mushy old clay that we knew would mean in the future, these areas would make fairly successful wetlands. Next slide, please. And then the next step that Karen mentioned was actually using a technology called ground penetrating radar that would really help us visualize where the wetlands used to be and how much they covered the area that we're looking at doing restoration. And so working with NRCS in November of 2019, we actually pulled a box that held ground penetrating radar within it across the areas that you see colored here on the map. And we pulled to this box back and forth in transects. And then the software that we used with that ground penetrating radar was actually able to tell us how deep the peat, that organic soil, was within particular areas that we were looking at. And the deeper the peat, the older and most likely more historic wetlands existed within those areas. And looking at the bog itself here, in this picture, the darker the blue gets, the deeper the peat was in the areas that we surveyed. The presence of peat indicated historic wetlands. The presence of really deep peat that was then most often underlain by that clay that we found indicate spots where we'll be really successful at creating wetlands in the future. These are areas that, as long as we can restore the hydrology that most likely existed before, will still hold wetlands because the history of the soils are there. Next slide, please. So one of the next steps in exploring and designing how successful our wetland restoration will be on the site is that we do need to figure out what the current hydrology is, and we're going to tie that to some water quality work as well. Cranberry bogs themselves are highly manipulated in order to be functioning agricultural cranberry bogs. And you can see on some of these pictures here, Windswept has various dikes, drainage areas, metal and concrete constructions that were put in place in order to direct the water where it needed to go for agriculture. There are also some areas, as in the picture on the left-hand side, that are natural seeps and natural water flows that are coming into the wetland even before we do any restoration. So one of the biggest projects that we need to do is figure out where is surface water coming from, but also where is the groundwater. So if we take out these control structures, if we move the agricultural control of hydrology on the site, will water still move where it needs to go, or do we need to adjust that and work on that? Will there be enough water to maintain the kinds of wetlands that we want to maintain out there? So one of the projects that we're hopefully going to embark on this winter is doing that monitoring to figure out where the water is going, because it will help inform where we'll be successful at creating wetland restoration. And then adjacent to that, we're also going to examine water quality now as it exists within the bog prior to restoration and then afterwards, because one of our goals is to improve the water quality in the site and of the water that's exiting the site. Next slide, please. Now, restoration on this site, given the fact that we're going to most likely do a lot of manipulation of the soils and changing the hydrology as it moves through the area, we're going to significantly change the plant communities that exist out there. And so one of our objectives is to track how new communities are developing and how that's related to our restoration actions. Initially, we're going to document plant communities pre-restoration, which we actually did this summer. You can see in yellow the transects of the vegetation communities that we plotted out on the bog itself. And knowing what's there now will help us plan for what the restoration communities are going to be in the future. So we documented prior to doing anything, we expect some significant restructuring of the bog through restoration. And then we'll actually track the vegetations that communities that develop naturally and hopefully document success of new wetland communities out on the site. We are working in partnership with Dr. Chris Neal at Woods Hole, who is conducting cranberry bog chronosequence research across New England. And we're able to incorporate the work that we're doing at Windswept within his research as well. Next slide, please. One of the other pieces we'll be able to explore through this research is what drives the plant communities that we're attempting to establish out on the bog itself. We can adjust the soils, we can adjust the hydrology and say this is exactly the kind of wetland that we're going for. But there are a number of things that impact the plants that will recruit into the site. And we're going to track some of those things. We'll be able to track soil moisture. Through our hydrology studies, we can track the levels of groundwater. We can look at nutrients, both within the soil and within the water, the kinds of soils that we put in place, and the actual restoration techniques that we use. And all of that information will go back to influencing and informing how successful our restoration was and what the outcomes of our restoration was within the site. And hopefully can inform other cranberry bog restoration work as well. Next slide, please. And with that, I'm going to turn over the presentation to our plant ecologist here at NCF, who will talk about some of the goals that we have for botanical work on the site.
So in addition to the wetlands, we were interested in finding out what was going on with the plants in the uplands surrounding the bogs. They've been handled differently and mostly sandy soil, but there's some interesting diversity in those uplands. We wanted to develop a plant community description of the current vegetation around the bogs. We wanted to map the rare and desired plant species and communities so we could protect them best during restoration. We also wanted to be able to target some seed collection so we could collect seeds and seed bank them for the future. When we do disturbance, we want to have some seeds that we can put back into areas to help speed the change over time. We also wanted to look for any invasive plant species problems that might require management so that we can do our best to mitigate those. Next slide. So one of the first things that you do when you start working at a site, whether you're doing an inventory or a restoration, is to build a species list and see what's present. So I spent a lot of time in 2019 and 2020 searching around the bogs on foot, looking for new species that we didn't know about and trying to figure out where plants were living. And we have over 327 species recorded to date on the species list for the Windswept property, which is pretty high. And that includes both the uplands and the wetlands. We added 3 species to the Nantucket flora list, which were species that had never been documented on Nantucket before. In some cases, those are native to the region and they just happen to be found now and hadn't been seen before, but in other cases, they could have been introduced by cranberry bog activities. The Korean longgrass on the left-hand picture, this is a species from Asia and it's a really aggressive turf grass. We weren't happy to see that, but it informs how we do our restoration project and what we might want to do with seeding and management. Rough buttonweed is a native of the Northeast and its native range approaches Massachusetts into Rhode Island. And it's probably something that came from the cranberry bog activities. Trailing pearlwort on the right-hand side, the tiny little plant in my fingers, is a native species of the region. It may have been here all along and just overlooked. Next. We also wanted to categorize where the rare species are in the uplands because we know we're going to be doing a lot of work with heavy equipment. And by defining those areas, we can try to figure out where we already have really high quality areas of plant life. And we can also kind of limit the activity in those spots. We had some species that we already knew were on the site, the sandplain blue-eyed grass and the blazing star liatris. But we also realized quickly that there were a few other species. So I ended up spending a lot of time this summer searching by walking back and forth across the upland areas and finding areas of St. Andrew's cross, which is a state endangered species, and also some Stew's bush clover and a large population of sandplain flax. All of these kind of give us an idea of really the highest value sandplain grassland areas. Next slide. So there were also some species that were rare for Massachusetts that were in the wetlands, and we'd already documented those. We had data from 2019 of the world marsh pennywort near bogs 14, 13, and 12. And we also knew that there was a population of creeping St. John's wort near bog 1, but we also found another population of that species near bog 8. So this helps us figure out what we're doing because we're going to be filling a lot of the ditches and these species live along the edges. Next slide, please. So looking at all this information, we can kind of make a little prediction and also kind of guide the upland vegetation towards a mixture of mesic grassland, which are moister grasslands with species like the Indian grass and the big blue stem, and some species that like wetter soils. Those are the darker green hatched areas, and the lighter green and white hatched areas would be ideal for sandplain grassland based on what we have there, and also areas to the south that would be filled so we could create a surface that was best for sandplain grassland based on them being higher elevation. Next slide, please. So we also found some unexpected botanical features in the uplands that we were able to map with GPS units. So even though they're uplands, they're not really technically uplands because they have wetland species growing in them. There were some areas of cranberry that were naturally growing in the midst of grassy areas. You can see that in sort of a darker purplish color. And then we found really large areas of Rexia, Xyris, Drosera. So meadow beauty and hard to remember all the common names. Yellow pineapple flower, I'm just going to call it Xyris, and Drosera, the sundew. So these areas are really amazing with thousands and thousands of plants and high densities. And we didn't expect to see them. We want to try to protect those as wetlands. They're probably just wet because they're slightly lower than the surrounding vegetation. We also found some really large populations of the elytras, which is also called colic root and unicorn root. And these are really special areas, and they can be sort of added to the mesic grassland areas and managed together, but very unusual. Next slide, please. So next up is Libby Buck, and she'll be talking about windswept bird surveys.
Thank you, Kelly. So for my aspect of this project, I wanted to jump right into what are the birds doing on this property. And as we're turning this back into a wetland, tracking the avian populations are really critical because they are extreme indicators of how the wetland health could be. And because birds are constantly looking for healthy food source and fresh water for survival. And windswept has excellent habitat for all these species, and by doing these surveys it will give us insight of what are the birds doing prior, during, and post the restoration efforts. So we decided to zero in on the bird species that are in critical need versus the birds that are such as songbirds who are thriving at windswept. We selected the secretive marsh birds because all over the world many species are declining because of habitat loss due to development or natural causes, and windswept would provide excellent breeding habitat for them. Also, many shorebirds are on the decline as well because of habitat loss. Some depend on wetlands for nesting habitat, but they also depend on stopover areas to complete their migration. Many shorebirds travel thousands of miles every year, and their lives depend on these stopover areas to help replenish their flat reserves so they can complete their journey. Nantucket plays a crucial role as the stopover area because it's located in the Atlantic flyway of many of these migrating shorebirds. And as they fly over, they're looking for these open sources of water, which windswept could definitely provide. And then we also wanted to survey for the threatened, endangered, and species of special concern, just to make sure that we were positively impacting their habitat. So this was the first year, the preliminary year of the study. It was decided that I was going to do weekly point count surveys. So I set up 7 different locations within the bog and spend 10 minutes at each recording the birds that I see and hear in that time frame. While I'm doing that, with brief pauses, but also I am broadcasting these calls of the secretive marsh birds because the only way to detect them sometimes is from their call because they're secretive. So I did these from May 15th until November 1st, and the time frame was chosen to make sure that I get the spring and fall migration and also the breeding seasons of certain species. Next slide, please. Since this was the first year of the survey and we haven't altered the bog in any way, out of the 22 surveys, I found that the Virginia rails and the northern harriers were the only species actively using the bogs. Once we start making some more restoration decisions, which will include adjusting the water levels, this will change the bird trends dramatically. Lucky for us, we have already seen this in our other bog at Milestone Cranberry Bog, which is much larger and actively harvested. It was decided several years ago to decommission some of the back bogs by changing the water levels and flooding them. And shortly after, from local bird watcher observations, many shorebirds, even rare, started showing up at the flooded area, and we're taking advantage of these new muddy locations and fresh water. Next slide, please. So most of these birds on this slide were already seen at Milestone, so that is promising for windswept. The only 2 that haven't been seen are the yellow rail and common gallinule. but those both have records on Nantucket, and Windswept would be a great potential habitat for them. Since this is just the first year, I still have to do many surveys, and I can't wait to see what else, what other species will be attracted to our restoration, but the options are really endless. I'm gonna turn it over to Danielle O'Dell.
Thank you, Libby. All right, I'll be rounding out some of the work that we're highlighting today, and I'll tell you about our spotted turtle research. So spotted turtles are small, secretive, semi-aquatic turtles that are really long-lived, with some of them known to live more than 50 years. They're uncommon throughout most of their range, with some states listing them as threatened or endangered. In Massachusetts, though, they used to be listed as a species of special concern, but that designation was removed in 2005. However, spotted turtle populations throughout New England are currently undergoing potential for an evaluation for potential for relisting. And despite their rarity elsewhere, Nantucket actually has relatively robust populations of spotted turtles. We have conducted studies on them for many years on several nearby properties, including Squam Farm and Medowie Creek. But the status of spotted turtles at Windswept Bog is basically unknown. Next slide, please. Spotted turtles are pretty picky about where they want to live, as opposed to snapping turtles and painted turtles that are really habitat generalists. They're very common, and they inhabit just about any body of water, whereas spotted turtles prefer shallow wetlands, vernal pools, cranberry bogs, really shrubby swamps, and shallow, slow-flowing streams. They're active from April through October, with the highest levels of activity in the spring and early summer. They hibernate throughout the winter underwater, often with other spotted turtles, snapping, and painted turtles. So learning how they use habitat in Windswept in the spring and the summer is important, but it's most critical for us to learn where they go in the winter to hibernate, because we anticipate that once we start a restoration project, the majority of the actual physical restoration work would most likely occur in the winter time. And that's going to be a time when turtles are hibernating and would not be able to move or respond to any kind of disturbance. Next slide, please. So in order to learn how they use habitat, we first set traps throughout the property, mostly in the ditches on the edges of the cranberry bogs themselves, but also in some of the surrounding wetlands. And when we capture a spotted turtle, we measure them all and give them a unique mark. Those unique codes allow us to know that we've already captured that turtle before and who that turtle is. And then a few of the bigger turtles will receive a small radio transmitter that we attach to the back of their shell. And that allows us to follow them with radio telemetry equipment throughout the year, and helps us find where they move throughout Windswept. This also allows them to track them into the early winter, so we can figure out where they're hibernating. Next slide, please. All right, in the image on the left of this slide, you can see all of the locations of the spotted turtles that we captured at Windswept. In 2019, which are the green dots, we captured 25 new adult turtles. And in 2020, the blue dots depict the locations of 33 new turtles that we captured, plus 10 recaptures from the 2019 season. In 2020, we also captured 5 hatchling turtles, which is very encouraging to us because that indicates that we do have a successful breeding population at Windswept. In the image on the right, it looks much the same, but these are the locations of turtles that we found through radio telemetry. So these are the turtles that had a transmitter on their back that we followed throughout the season. And then this is all of the sites where we have relocated each of our turtles. So while we find and track the turtles throughout all the bogs at Windswept, it appears that the greatest density of turtle activity actually occurs kind of right smack in the middle in the vicinity of Bog 4. And that abuts a very large, dense, shrubby wetland. In 2020, most of our transmitters lasted into December, and the final locations of 5 of the 6 turtles tracked this year are designated on the slide, on the image on the right-hand side with the red turtle icons. So 5 of those turtles were last located in wetlands bordering Windswept rather than in the bogs themselves. And 1 turtle, the transmitter actually died before we could find its final hibernation site. So unfortunately, we only got 5 out of 6 turtles for their hibernation locations. While our sample size is low, we are encouraged that so far most of our turtles seem to be leaving the bogs to hibernate in the neighboring wetlands. Next slide, please. So that's all that we have for you today so far about our Windswept project. Any of us would be more than happy to answer any questions. Feel free to call us at the office, or our website has all of our email addresses listed on there, so you can figure out how to contact each one of us. Thank you very much for listening.